Hi guys, welcome back. This is the 5th episode of our DevOps learning series. Today we'll be discussing about containerization with Docker. If you have missed any of our previous episodes, you can check out the link above. If you want to learn DevOps and get globally recognized certificates, you can check out our DevOps course. The link is given below in the description box. Let's start the video now. Alright, let's talk about what is containerization, and we'll be discussing about Docker in this case. Docker is one of the best tool to perform the containerization environment. But first of all, you should all understand what is containers, because that is the trend in the market at this moment. People are using Kubernetes, people are using Docker containers just to have eliminations of old virtual machines and the OS stuff. So if I talk about old legacy of computer systems, so we used to have operating systems, and operating systems can be run on any of the hardwares. So let's say we used to have the laptops, on the laptop. Let's say if you purchase any new laptop, you have an operating system called Windows or Linux, for example, set up on this machine. So for that, you need to have a BIOS on top of hardware to communicate to the software. Then you used to have the entire OS. So when I say entire OS, what does it mean? It means all the libraries, all the plugins, all the softwares which are required for an OS to run. Okay. That has to be there on top of it. And then after OS, we used to have our own applications, let's say VLC media player, or let's say any music softwares or anything like that. You can have any application on top of it. But the problem with this legacy method was that this OS itself, because this OS is not a lightweight, it's very heavyweight. Because if you see any ISO image of any operating system, it's minimum 4 gigs, 3 gigs, 8 gigs, depending on what OS are you using, right? Because it is a complete package. So just think like your application which are required to execute, it needs some platform where the application can run. So earlier, they used to have this OS, on OS only you can execute the applications. But with the time and the trend change of the industry, from the operating system, the typical laptop or computer systems, desktop systems, we came into virtualizations where we used to have a virtual machines. In the virtual machines, we used to have multiple OSs. Let's say I am using one single laptop. On single laptop, I am using a layer of virtualization, which is called a layer of virtualization, which can let me have multiple virtual machine V1, V2, and V3. This is my hardware. Okay, and in this virtual machine, I can have OS Linux. This one I can have OS Windows. This one I can have OS Mac. So I can use multiple OS on top of a single OS with the help of virtualization layer. But that is also another problem, because that is also having a heavyweight OS installed, which we don't want for our application to run. Because see, if you are having such big and heavy loaded OS on your machine, definitely it is going to take storage, it is going to take your network out bandwidth, it is going to take your resources in terms of CPU, memory, hardware, storage, and etc. Right? So those things, to eliminate those things, the industry evolved, and they brought up a concept called containers. So containers are nothing but, let's say I want an application to run, which is what, let's say web server. So I want to run an application called Nginx. So I just have to have an Nginx application, nothing else, to execute that OS. Onto that OS. So I don't need any entire operating system. I can just directly deploy my application, and then I can use it. So for that, this container technology came, where you have a layer of containerization which can support multiple applications to run, rather than just think like, earlier we have a virtualization, now we have a container layer where it supports the container applications to run in isolated. So let's say if I have 3 applications to run, I want Nginx to run. Okay. Also, let's say I want to run some web server, HTTP or Apache. Okay. Also, I want to run some Python application. For example, I'm just thinking here. So I want 3 applications to run on my machine, with the help of container layer, what I can do is I can just have 3 applications to execute, and then this will support in the single platform of your which supports the containerization, and on top of it you can have an application. So this will not consume much of a resource, and it will be like very quick to deploy the applications, because it is not requiring much of an resources of your hardwares, because it does not need any OS specifically. So that layer of containerization, there are multiple tools to that to support that layer. The Docker is one of the tool that we'll be talking in this session here. So Docker support containerization. Containerization is a technology which can have multiple containers of applications, and those are all isolated containers. You can deploy a number of applications. It does not need the main source of your hardware like resources. It can have a very minimal image, whatever the image of a particular application, that's all it requires, and after that it can deploy things for you. So that's why we call a container is a lightweight OS. It's like very light, just an application it requires. You just need that application only and nothing else to run it. So this is the advantages of using container. Later in the session also we'll be talking about, in the next session, Kubernetes, where you'll be managing all the container systems and stuff. So let's go to the Docker and see how does the Docker work and what is the Docker, how do you download the Docker. Okay, so I'll just show it up here to you. Yep. So if you go to the docs.docker.com, this is the official website of Docker. You will find the installation setup for Docker desktop. So you can download for Windows. This is you have to download a package for Windows .exe file. If you're using any ARM based hardware, then you can download this one, and then you can just set up like this. I'm using a MacBook, and I already have Docker desktop set up on my machine. Okay, with my account I have already logged in and stuff I have done. All right, so and here it tells me the stats also, like how much percentage of CPU is being used by the containers, and how much memory is being used by the container. So you see my hardware memory is 16 gigs, and out of it just 2.3 gigs is being used by the containers. If I would have deployed multiple OS on top of my base machines, then it would have been consuming more than is what I'm expecting. And just to see it up here, right? So once you have downloaded and set up the Docker, you have to download a plugin as well just to communicate to the Docker. So Docker is a plugin. You can use brew install for MacBook, or apt-get for Ubuntu, or for Windows also you will find the packaging for the Docker. So once you have that, just to check the version of Docker, you can run command docker -- version. It will tell you that currently I am on 27.5.1. This is my build version of the Docker application that I'm using. All right. If you want to see the information about Docker, so it will tell me all the information, what my Docker is, what is the client I'm using. All right. After that, what are the plugins that is being already downloaded or installed and set up to my Docker machine here. How many containers I am currently available on my server or this machine, and how many out of 26 is in the running state and 22 are in the stopped state. So containers means you have seen the ideology before, right? So it's like an application, think like an application, direct application. So I had 26 applications before, out of which 4 are running into the current state at this moment, and 22 applications are currently in the stopped state. So it's very quick to start and stop the containers also, because earlier just think like, you want to run a VLC media player on a OS, so you have to build a OS, and once the OS is, you have to boot it up again, and then it will take some time. Containers are like within seconds, containers can be deployed within seconds, you can use them, and then you can terminate also. So that is why it is very large, very lightweight, it's very fast in order to usage as well. So that is advantage. Then it is telling me some stats of the storage driver it is using, and then C group version for grouping internally, just to make it isolated. So it uses C group technology of Linux. Then other things about the kernel, whatever I am using, then operating systems of Docker things, and the proxy details if I have any proxies here. So it will tell you all the information about your Docker related, whatever the Docker containers that you are using. So if you want to see all the containers, so docker ps is the command. It will tell you these are the containers which are currently running state. And if you want to see all the containers, so I have currently 1, 2, 3, 4 containers are running state. If I want to see all the containers which were stopped also before, so you will see here all the lists. So -a can give you details about all the containers. So these are all exited, which means that they are no longer running in this state. They are exited 11 days ago. Whenever I did something, at the time it was running. After that, it got exited. No longer using the resources of my hardware here. Okay. So this is how you can just use and see things. Okay. Now, if we talk about how do you build a container, how do you log into container machine? So we will do this. Let's say for Ubuntu, I want to have an Ubuntu as a container. Ubuntu OS, the entire OS of 3.5 gigs, just in the form of containers. How do you do that? So for that, you need an image actually. So an image is nothing but uh, basically the application. Just think like Ubuntu is also an application, like VLC player is an application, or any other music applications or anything. So Ubuntu is also an application. It also has an image. Like earlier we used to use .iso image for OS to have it. In the world of containers, we also have an images for any applications which are available publicly. So Docker pull command can pull the images for you, whatever is available on the public repositories. From there you can just download the image, and after that you can deploy the images, right? So I'll just pull it Ubuntu. If I already have pulled it, it will be stored in my image cache, and then I can use it a number of times I would want to. Okay. Now it has pulled it. After that, I am going to run this. So what I'm doing it in the interactive terminal mode, I am just going into my container. So I'm starting the container as a Ubuntu machine, and then I'm going inside. I want a shell to have the shell, interactive mode. See, just to show up here. So this is my MacBook, and as soon as I go inside this, I will be having Ubuntu. So this is my Ubuntu machine. So now you see the font has changed here. Also, you name my phone. So this will tell me the kernel version of the Ubuntu machine, whatever is being there. And it is like very minimal setup. So it is not having much of a things. It's like very minimal setup of the Ubuntu, which is required to perform anything. Now here I can make any changes. I can create directories. I can create files. So this is happening within the containers. It's not happening on my local machine. So if I go exit from here, Control D. So I have exited. If I do ls-al, you will see a different set of directories and file is what I was seeing earlier, right? So this is how you can just identify. Yeah. So this is the version of your Ubuntu. Currently, it's 24.04.1. Okay. This is the distribution release. Or with the exit command also, you can exit out of the container. So this is how you can build a container. So since I have already exited, it will not be visible here in the ps command because I have already come out of the containers. It's so because I logged in as an interactive. So this IT is an option, gives you interactive mode shell to log into any machine where your container application is running. Then I guess Docker help can give you details about all the options that you have it. Whatever the options, it has a lot of options to see Docker related, container related. So you can just explore those. And also if you want to see the guide, you can just go to here and then go to this guide also, and it will walk you through about what Docker supports and what kind of a management systems it has it for the containers and what all commands it has it for the containers. So you can explore all these. So it has all the documentations ready for the people to explore. Okay. All right. Now let's try to run some some script or some packages that we will be storing as an image. So what you can do is like what is the advantage here we will be seeing with the help of Docker. So we will be making some changes in the code. We are making some packages. Those packages we can build as a container as an image. So later if we need the same setup again, we don't have to do manually repeat the same setup. So we can store as an image. So think like a snapshot, right? So your machine, whatever the stage of your machine at this moment right now, you just take a snap of it, which means later if you want to resume it from there itself, you can use resume it. You can just use import that snap, and then after that you can similarly in the Docker also, whatever the state of your container at this moment, you can store that state of your container in the form of image. Later, not just you, anybody can reference your image if it is publicly available in the Docker hub. From there they can download the same image and then they can use it. So there have been a lot of images have already been published onto the Docker hub. We'll be seeing in the later in the session, that from the Docker hub you can download the image. So whatever we did Docker pull, that is also downloading from the Docker hub itself. The repositories of the Docker, where it is all the images of important or not just important, like all kind of applications which are there in the market, they are freely available. You can just import it and then you use it. Okay, so let me just go to just go to Docker. Okay, I'll go to my app. Okay, inside my app, there are multiple files you are seeing here. Okay, so what are these files? We'll be talking about that in bit more. So in order to create an image, you need to have some setup to be ready. So we'll be discussing that in detail here. Okay, let's talk about this file. So first of all, I have created a app.py. This is nothing but a Flask application. Okay, it's running mainly on port 5001, and this is the function, home function. It says hello from Flask in the Docker. So this is my application. Okay, now this is the Docker file. So Docker file is very important, and it's named as a Docker file itself. So what it says that whenever you are going to build any container, so this take a reference of the Docker file, and it explains the structure or the steps that is required in order to build a container, and what all actions will be performing whenever you are going to create a containers, right? So this is the Docker file. It says from Python 3.11, we need Python 3.11. Working directory of the container would be /app. We will be copy all the requirement.txt to the local home directory of the Docker container. Okay, after that we will be installing some requirements, whatever the requirements we have. So if I see the requirements, so we will just be having Flask. So the container that we are going to build based on this setup, the application, that container will be having a minimal application called Flask. Okay, once it basically download and install the Flask, and then it will copy whatever is present available here all to the Docker container. So this is what the copy explains here. Now there is a very interesting thing, and it's very important, you should focus towards this. What is the differences between, in the interview also sometimes people ask, what is the differences between Entrypoint and the CMD? So it's very interesting. So entry point is something that cannot be replaceable, that cannot be changeable. Once it is there, it has to be work, it has to be add on. So this says that any command that you are executing, so this is the default command. Okay, this is default, it cannot be changed. It can be changed only by if you passing an entry point as an option in the command itself. Otherwise it will not change. So this will always run. It will let the container forcefully run the command that you are providing. So that's why I have made up Entrypoint Python, and CMD is app.py. So instead of Entrypoint, I could have given in the CMD itself saying that Python space app.py, which means this is my Python script. I want to execute this script via Python package, because it's a Python script, but I want that Python to be defaultly, forced to let my container execute. And after that, I can change this app.py also on the fly. When I execute the container, I can replace this with any other argument saying that no, execute this Python file rather than executing app.py. So this CMD can be overridden, but entry point cannot be overridden. It will let the container forcefully execute it until you are providing -- entry point option there. So this is very commonly question is being asked in the interview when we talk about Dockers, the differences between entry point and the CMD. So CMD is like any command that you can execute, but it can be also overridden. Entry point is something which makes it default for your containers to run, and after that you cannot override also. Okay, right. So this is the thing that you should always remember. Okay, so now the container that we are going to build based on this my app setup we have, it is going to have a PyTest this Flask application, and then after the Flask application it will be deploying on port 5001 on the local host. Okay, now I'm going to build it as an image. Okay, so I am just naming it 2.0, and this is the command to build any package, of any files. To build a package, you can use docker build command. This is the tag I'm doing. I'm tagging my application as my app colon. This is my tag version 2.0, and dot means take all the files, whatever the file I have of this application. So it will just build it for me. It will take some time to build it because it has to do all these checks to perform. So you can just see step by step, and then you can just see checksums also. It is basically trying to compare and then validate those checksums as well, and it will give you all this. So it's basically loading the image for you. It is creating an image of whatever your containers are going to have it based on this my apps applications. So it will just take few seconds just to build it. So it's saying the steps actually out of 10. Currently it's at the fifth step to build that image for me. Okay, we will let this run, and just zoom it a bit. Yeah. Now see, step by step whatever we have provided here, it is basically picking up. It was picking up actually the fourth step just to copy the requirement and downloading. So it has built all these steps which are required for docker images to build, and it has ready actually. So now if I say docker images my app, I'll see there are two tags available. One tag 1.0 was built 11 days ago, and 2.0 that we have built as an image, it is 22 seconds ago. And this is of size 1.03 GB also. So this is like, think like this. So this is the application. We'll be running this application as a container. So this application is still like very lesser weight because it is somewhat complex like a Flask application, but still lesser than the weight of the OS and then application on top of it. So that's why it's always better to have a containers, and to run a container you need an image, because without image containers cannot be deployed. So to have an image you can build the image based on the files that you have which are there in the Docker important files. So these files were important, so Docker file was important, and then since this Docker file has some validations in terms of having this application's necessity requirements.txt, that's why it builds it. Otherwise a Docker file can also be a very simple file. In that case the image size would be very simple. Okay, so now I am going to run this my app 2.0. Okay, so let's see if it runs, or if it runs with this. So this will be like running on the Docker itself. Okay, so this is how you can build an application. We'll be seeing multi-container application as well later in this session, where we'll be seeing we have a web hosting, and after that we have a database backend to it. Multiple containers are integrated to each other, so we'll be seeing that setup as well. Maybe there are some security rules I have applied here, that's why it's unable to pick it up, and then some networking thing has to be sorted out. Otherwise it should supposed to basically pick. Yeah, it's picking here. Cool then. Or I am already using this port actually for my multi-container setup before. That's why it is not letting me use that. Yeah, that's why, because I am already using this. So I have to close this and then I have to open it up. All right. So anyway, so what we'll be seeing next is Docker Hub. You know what is a Docker Hub? So if you go here and then you type Docker Hub, you will see, or here also in the Docker desktop, you will see all the images, and you can go through the Docker Hub. This is the platform where all the Docker images are present. The images can belong to any technology. It can be AI technology. It can be machine learning technologies. It can be anything. It has all. It's like a central repository kind of a thing, where it's a platform where everybody is contributing to that platform, and whenever somebody make it publicly, you can just download it, any images. So if you go to the images, this is the if I go to hub repositories, so I'll see all the repositories which are there. So currently I am in this thing, and these are my local repositories, but hub repositories also would be available. If you usually log into it, I have some restrictions actually, otherwise I would have been showing it up here, all the repositories. But when I do git pull, the Docker pull, it was able to basically pull the images from the Docker Hub itself. And if I say my app, so you can see my app, which I built earlier. This was available in the form of Docker Hub. So this I already pushed the image onto my Docker. So next time if I would want to use that same image to build a container on top of it, I am able to pull it up actually. So that is the advantage of being using the Docker Hub. Okay, so this is the application. Okay, if you want to actually push to the Docker Hub, how can you do that? So currently my Docker Hub has my app tag version 1.0, but I want to push version 2.0 also. So I'll just quit this session first, and then I'll say git, sorry, I'll say Docker. Since I've already tagged it, I'll tag my app 2.0, or I can just do Docker push also, my app 2.0. Okay, so this will start preparing whatever it requires. So it's denied. Okay, so what I'll have to do is I have to specifically tag it with my Docker account. Actually, this is my Docker account. First I tag it and then I can push it. Okay, yeah, so I have to tag it with the Docker account which I have logged in. Otherwise you will get error, resources access denied, because you have to integrate with the Docker account that you have logged in. So I have logged in with this Docker account, and that's why I was able to only tag it and then push it the image. So once it is ready to push, you will be seeing that image will be highlighting here in the Docker Hub itself with the tag 2.0. Yeah, 7 minutes ago created. It is listing all the things, but let's push this. Currently I have yeah, okay, this will take some time because depending on the size of the image, it takes time to prepare it and then push it up. But it is very lesser weight than what typical OS legacy method it was using before. So to build an image and then push it. So the last chunk of it is getting pushed to the Docker Hub. The rest everything is done. So, and it depends on your internet speed as well. Yeah, it's all pushed. So let's just wait till it completes. Perfect. So it has provided me the checksum value for this and to validate the size also. And then now if I go and refresh it again, yeah, so it has listed me here. What I can do is like I can start it from here as well. So you can just run and then you can see, oh, you don't have to directly go to here and then say Docker run and choose that image. Once you have pushed to the Docker Hub, from the Docker Hub itself, you can just build a container. So this is the container, and containers are always being like randomly being chosen, and then it will give a name of specifically who has designed the container technology, right? So that name will be added up here. So whenever you create any new container, so the new name with the container ID will be given. So this container is having my app. That app is nothing but kind of a web app, which will just print the application to you. Let me do this. Let me just quit this for a moment, and let me just show it up. Actually, this will be making more sense. Or I could have done compose down. Stopping. Yeah, cool. Now if I do this, see if it runs. Delete forever. We run this. Yeah, it's not letting me run. Localhost. Still not running. Maybe this port is used. Something else. It says it's active. 27 5001. Anyways, so it should work actually. But we have seen that this is how you can create a container based on your image that you are you can deploy it with the help of Docker Hub. All right. And if we talk about the Docker Compose, so there is another method actually to build the images, and then you can have which is called Docker Compose commands. So Docker Compose, I will show up a demo here for multi-container setup. When I say multi-container, so think like an application which has a front end and which also has a back end. So we'll be deploying application as a front end of a web application in Nginx, and the back end would be any database, MySQL or Postgres. So it will give you an idea that two applications can also integrate to each other, and both can be integratedly work depending on the whatever the input that you are going to provide. So it will pass on the same output, fetching the data from the database and then pushing it up to the front end. So this is the setup for multi-container app. So I have created Docker Compose. So with the help of Docker Compose, we'll be building that, not just with the Docker. So I'll show up to you. So this is my Docker Compose file. It says that create a service, actually database service. Okay, it will be using port 5433 of local, and this is of your container port 5432, and the same port 5001 it will be using. Okay, and this is the Postgres I'm basically trying to create as a database. Okay, and if I go inside app and go to L, here I will show you what Docker file I have created. So I'm using just a simple copy requirements, and then in the same CMD itself, I'm not using Entrypoint here because it's just a basic script that I would want to execute. I don't need any override also, so it's fine. Okay, this is my Docker file, and if I see the requirement.txt, so this is the requirement.txt. It is using Flask application and scicopy G2 application. And if I say app.py, so app.py is nothing but basically a Flask application code. What it is doing is that on the port 5001 local machine, it will open a channel for me to interact with the database actually, and then it will execute the database command create table if not exists with a message, whatever the message I would want to pass on. So and then this will I will pass. So I'll show you like how does this basically working. This will basically list me index.html page. That page will allow me to provide any message. Once I submit the message will go into the database because we are using insert here. And once the database is submitted, and then it will pull back the message from the database by using statement from the database itself. Okay, and if I look at the index.html, so this is my index.html look like. So this is just a message post actually. So let's try to run this and then see, we will understand more of how does this multi-container setup is working for the Docker case scenarios. Okay, so let's run this. We'll use docker compose -- build. Okay, docker. So this is a command to build the docker compose actually. Okay, yeah. So this is how I have written the index.html page. Okay, so if you see it here, this was my index.html. It says it's written in the HTML actually. So this is of multi-container application. It's asking enter a message is what I am saying it here. Enter a message, and then whatever the message I will type, it will be taken as a post method of HTTP, and then it will submit. And once you submit it, after that it will basically return that message to you in the form of fetch the data from the database. So let's say we'll start submitting something. Hi, hi star agile, and let me just zoom it. Star agile. Okay, and I submit it. Once I submit it, what happened is once you submit that, it will trigger this insert actually. Okay, before that, in order to make a database connection, at that time itself it has already created a table. Okay, if it is not created with the table name messages, okay, which has column id, which is a primary key, serial is a primary key, then text as well as, then if you are submitting the data from that form, it is basically inserting into that messages table for you. And once you click on submit, it is basically doing a select query of the text from the message actually. Okay, if I do id, it will print me id rather than a text. Okay, so this time it is giving me the text back. So I'll say Himanshu and submit. It is printing me the value of whatever text I have given. It is given me back. So this is how the multiple containers are being interactive. So this front, whatever you are seeing at this moment on the screen, is nothing but HTML. Okay, and that is being part of the Flask application, because that can leverage you to run a index.html page, but it also has an interactive communication to the database, which is a Postgres in this case. It is communicating to that database, connecting, and then whatever the data I am providing up here, it is going back to that Postgres and then able to fetch the data. And then if you want to shut down this docker compose, so you can just provide command docker compose down. It will automatically shut down the containers for you, whatever was running actually. So let me just stop this, because it's a heavy application, a little heavy. That's why it is running. It is taking time to yeah, run it. Python app. Yeah. So let's do some modifications actually and then see. So instead of select text, I want to select ID and text both. So earlier we are getting the text message whatever we are submitting, but I want ID also, which is being stored in the database, though it's not needed, because consumer should not know what is there internally to the database ID. But I'm just playing around with this setup and just to see how do you tweak that actually, just to give you more hands-on. So let me just try this. Let me just save it and then build it again. Okay. So it says that database system is ready to accept. Very good. Let me refresh this. Continue. something wrong in the setup. Database is up, but the Flask is not up actually. There are some errors we are getting actually here. Database URL, init connectivity. Saying that could not connect, connection refused. Okay. Not sure why is it saying this. Let me see. If I kill this. It's fine up 9 minutes ago. Let me restart it. Okay, yeah, it's saying because I am inside .app, I have to be present here. That's why, because it was just picking up the app. It was not picking the actual Flask application. So this time I'll just do this, and yeah, now it's running. And let me, yeah. So like, let's say if I say Himanshu and submit it, this time it is giving me just the ID. It is not picking up the text, though it should actually, because I changed the modification in the code to have ID as well as the name, ID as well as the text, but it is giving me the ID. And one more thing you just notice here, whenever I refresh this, okay, you see a new entry. It's like a HTTP logs, right? The logs have been generated from this IP address as a source IP on this timestamp. Somebody is doing a post call, and then let's say if I do anything else, so the IDs keep on changing, so one more entry you are seeing addition is happening because it is basically capturing all the traffic, whatever is coming through this Flask application. Let me just shut down this again. Compose down. Let me make some modifications to yeah, py select ID comma text. It's not just taking text. Then what if I say ID comma text for messages? Okay, order by ID is fine. I'm just playing around with this and then just to see, what it behaves and how does it do. But yeah, you got the idea actually that this time also it's giving some error. Connection could not be established. Let me start again. Error docker app.py request. Maybe it's unable to recognize this. Yeah, it's just printing the text. You need to make more modifications to that application, but this is the idea of using multi-container setup where we can have n number of containers. So let's say there are some other use case of having a load balancer as an Nginx, and after that load balancer you have a main application, and after that main application you have a backend database. So you want connectivity to or integrations between all three platforms, all three applications. So you can create 3 containers to that, and then you have to just manage about networking between communications of all these containers. So this is how you can use the multi-container setup. So that is kind of an advantage of using with the help of Docker, because it's very containers are very lightweight, and the Docker can help you build the images, and then later you can just create containers and applications on top of it. So Just wanted to give you an idea about how does you identify or play around with the Docker in the form of containerization technology that it performs. Okay, and I'm not sure if we can just see Docker logs or something here. Yeah, you need to provide the argument of in the form of container, I believe. You can check the logs also for the containers, what is happening to that container actually. What is the name? Is this the name? Or container ID? Yeah, so this is the log. You can see for this container some error happened. If in case, so you want to communicate and see, okay, this is the error that I'm getting, some TCP connections to communicate to the backend database IP port number. So this is how you can just track down on all the logs and fetch it from that container. So this is also another facility, right? So you should be having a proper visualization of the idea about what is happening to that containers. Otherwise, there is no point, right? So if application is failing or some issues with the code itself, you should be able to fetch those logs and then troubleshoot accordingly and then build the proper application. So yeah, so this is the advantage and this is the use cases of Docker container we would want to capture in this session for you guys. All right, thanks for watching. If you have got any questions and concerns, you can drop in the Discord channel. The link is attached in the description below. Till then, keep learning, keep smiling, keep growing.